Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In class 9th you have studied about circles, right? What is a circle? Circle is just a collection of points equidistant from a fixed point. Let us say this is a fixed point, okay? And if I take a collection of points which are at the equal distance from this point, then this shape is circle, right? Every point is equidistant from this point and this distance is known as radius, right? You are aware of the terminology used in circle. For example, the boundary of this is known as circumference, right? And this is radius. If I draw a straight line passing through the center, this is diameter, right? If I name it A and B, then AB is diameter, right? What is a chord? If I let us say make these points join, let us name these as CD, this is a chord, right? For that matter, if I take any 2 points on the circle and join them, it will be a chord, and the diameter is the longest chord. Diameter is the longest chord, right? As you can see, and this fixed point here, it is center of the circle. So diameter passes through the center, it is the longest chord. As you move away from the center, the chords will get smaller and smaller, right? And if you take any portion of the circumference, this is known as arc, right? So these are some of the things that you know about circle already. One more term is sector, right? So this portion which is between radii and the circumference is known as sector, right? And this is minor sector, and this rest is major sector, right? And if I draw a chord, and this area between the chord and this arc, right, is known as segment, right? And this is minor segment. If this is the center, then this is minor segment and the rest is major segment, right? So these are terms that you already know. Now in this chapter we will talk about tangents to a circle. What is a tangent? If you take a line, let us say this is a line and a circle, right? Now in this figure, this is a non-intersecting line, right? Non-intersecting line. This line is a non-intersecting line and this is a circle, let's say. But if these have to intersect, what is the maximum number of points at which the circle and the line can intersect? 2 points. So the maximum points of intersections of a line and a circle are 2, and this line is known as secant of this circle, right? This line which intersects the circle at 2 points is known as secant of the circle. And there can be another case where the line is intersecting the circle at just 1 point, right? So this line is intersecting or meeting the circle at just 1 point. This is known as tangent, right? This line is tangent to this circle, okay? So what are the maximum points of intersections of a line and a circle? 2. And if that happens, the line intersects the circle at 2 points, that line is known as secant of the circle. If the line touches the circle at 1 point, then this line is known as tangent, right? And this point here is known as point of contact, right? Where the tangent touches the circle is known as point of contact. Okay, so this is my tangent. We will study about tangent in detail in this chapter. First point here is, let us say this is a circle, okay, and if you draw a secant here, right, and let us say this is the center. Now if you keep moving away from the center, this secant will cut at 2 points, right? But when you reach at this point here, this secant will touch the circle at only 1 point. Now that secant has become the tangent, right? These are secants, these are secants. Now this is my tangent, okay, and this touches the point of contact, okay. Now if you take a wire, let us say you draw a circle on a sheet and you take a wire, okay, which is a straight wire, like a straight line, okay. You put that wire here, let us say this is my point of contact P, okay. Now you try and rotate this wire about this point P, okay. You cannot disturb this point of contact, the wire has to touch at this point at all times, okay. Now keeping it here, you rotate it about P. When you rotate this wire, you will see, even if the minimum rotation is there, this wire will start cutting this circle at 2 points, this and this, okay. Even if you rotate it this way, you rotate it clockwise or anti-clockwise, in both the cases it will cut the circle at 2 points, okay, if you move that wire away. Now, so there can be only one tangent at a single point. Let us say this is the point P we are considering, or for that matter you can consider any point on the circle as point P, and if there is a wire here and you try to rotate it so that you find another position for a tangent, you cannot find another tangent at point P, because as soon as you rotate this wire will cut the circle at 2 points, okay. So it will become a secant line, then it will no longer be a tangent. So from this we can say there can be only one tangent at a point on the circle, okay. The point P is on the circle, so there can be only one tangent at point P on the circle, all right. So this is first thing that we should learn, okay. Second thing is that if you have a circle, let's say this is my circle, okay, and you draw a tangent, right. If you join this point of contact with the center, okay, let us say this is O, this is point P. Now this distance OP is the radius, right, and this line is tangent, and this point P is point of contact, right. Now on this line, tangent line, if you take any other point apart from P, okay, you take any other point. Now if you join this point with O, right, let us take this point as Q and this point as M, okay. Now I have taken any random point on the tangent apart from P, right. So this distance OQ is what? This is OM plus MQ, right. And what is OM? OM is also the radius of this circle. So OM is equal to OP. So I can say this is OP plus MQ, because OM is equal to OP is equal to radius of this circle, right. So from this what I can say is distance OQ is greater than OP, because OQ is OP plus something, right? So OQ is greater than OP. Now Q is any point apart from P. Q is not a specific point. Q can be here, Q can be here, Q can be here, or anywhere on this line, right? Every time you take Q apart from P, you will see that OQ is greater than OP. So OP is the smallest distance possible, between the center of the circle and the tangent. Right? Now if you consider this as a triangle, let us say OPQ, okay, so you will see that OP is the smallest side, right? OQ is always greater than OP, okay, so OP is always smaller than OQ. So we can say that this angle is 90 degrees, because in a triangle the perpendicular is always smaller than the hypotenuse, right? So this is the hypotenuse and this is the perpendicular line, right? This can also be considered as perpendicular, this can also be considered as perpendicular, right? When you draw something like this line is perpendicular to this line and this line is perpendicular to this line, but these lines will always be smaller than the hypotenuse, okay? If you draw a hypotenuse here, this will always be bigger than this line and this line also, right? So this is the property of a right angle triangle. Now this is the right angle. So we can say that tangent and the radius are perpendicular to each other. Other way to think about it is that if you want the shortest distance between a point and a line is the perpendicular drawn from that point to the line, What I am trying to say here is, if this is a line and this is a point, okay, so there can be infinite number of distances that can be calculated from this point to this line, right? This distance, but the shortest distance is the distance which is perpendicular drawn from this point to this line, right? This is 90 degrees. This perpendicular distance is the shortest distance, because any other line will act as the hypotenuse of this triangle, which is greater than this, right? So this is what you can think. Now a tangent is perpendicular to the radius of the circle, okay, at the point of contact.